Hello. Okay, for today's lesson, we are going to be talking about tangrams. Now, tangrams have been implemented about 250 some odd years ago by the Chinese. And what they're a shape made up of 7 pieces. Usually the 7 pieces form a square. Form that real quick. Square. There we are. Okay. Typically when you buy them, they come in this square shape, and this is the overall thought process behind them, is that they form a whole square. Now, if this is the first time your children are working on tangrams, a lesson that is instructionally simple is having them create the square. There are numerous ways to do that. One thing with your GT students will be to see if they can figure out how many different ways they can build the square. So this will allow for student exploration, just for them to become familiar with the manipulatives. Now, in this case, I am using green manipulatives, but I have them set against a white piece of paper because you can barely see them on the table because of the contrasting colors, which is something to keep in mind, especially if you are working with students with special needs, especially visual impairments. Okay. Now, after they've explored, learned how to create the square, different things about the tangrams, there are printouts. These ones are relatively simple and can be used with younger elementary students or students with special needs because they have the lines outlined per shape. So for this one thing to be conscious of, which may prove difficult for some students, is that my tangrams are too big for these shapes, so they are overlapping a little bit, which I am able to still create the shapes, but students who have depth perception or visual discrimination issues may not do well with that. So just something to be aware of. Okay, there's my race car. Students can color it, which is also another good fine motor skills for your younger students. So, several things to use with those. There's also some that are a little harder. This one's a spaceship, and it does not have the lines in the middle, which allows for students to try the different things out. There might be more than one way to put it, but they need to use all 7 and create the shape. I have several others here, like the whale, which does not have the lines. But then I also have this one, which has the lines also, like the race car one, which will help out some of your students. Now, for the purpose of this lesson is to implement fractions. Okay. Let me build my square here again. Okay, there's my square. Now, when we teach students about fractions, or even anytime using graph paper, we teach them that one square is 1. Several squares together, you count by ones. For this unit, the tangrams create 1 unit. This whole piece is 1, which is why they're great with working with fractions, because fractions are part of a whole. We have the whole square. Now I need to figure out what each portion represents. These two are easy. Looking from here, looking at this portion and this portion, these 2 large squares are half of the square. 2 halves. So this is 1 half. You split the halves in half. These are each a fourth. Now these become your base for learning what everything else is. I strongly recommend using actual tangrams when you solve this one. They do have the paper cutouts, but they're a little bit harder to manipulate. And since there is human error when cutting them, they're not going to be as precise. And when finding out the fractions, it really helps when they overlay perfectly. So I would do my best to get my hands on an actual set of tangrams. But anyways, so for these, we realize that these 2 pieces equal a fourth each. Now comes the difficult part. How do we figure out how much each of these pieces are, especially the square, which we can try to fit into the big square, but we can see that there's this little square, which we don't have a tangram for, and these squares to the side. So we can't use our tangrams to create the large triangle. So these can prove difficult. The easiest one to start off with is we can use the medium-sized square. Let's see. Actually, even better than medium-sized, we'll use the smaller ones. The smaller ones fit. This tangram set only comes with 2 smaller ones, but students should be able to lay the 2 over and be able to tell that 2 of them make up half of the large triangle. So if we have a fourth, we know this is a fourth. These 2 make up a half of the fourth, which is 1/8. So together they make 1/8. Then we separate them, cutting 8 and a half again is 1/16. So we have one square is 1/16, another one that's 1/16. And then we can use those 2 to figure out the rest of the lengths, the rest of the sizes for the remaining tangrams. We take our 2 smaller triangles, and we can tell that the 2 smaller ones put together make up the medium-sized one. So this one will be 1/8. We can also see that when we overlay them with a square, they create half of the square. So the square is 1/8. And the rhombus we have, which when overlaid, there we go, is also, putting them together, is also 1/8. So we have the medium, the square, and the rhombus all equal 1/8. The small triangles equal 1/16, and the large triangles are 1/4. This is where it's a little difficult, especially with younger students who are barely learning fractions, because they might have a hard time understanding that the different denominators equal different portions. Which students, especially those that have special needs or with disabilities, it might be beneficial to allow them the use of the fraction bars, which compare the different fraction portions and compare them to one another. There is also a template that is attached that you may use for, it is exactly what I just explained, except it's already laid out and labeled. This is also a beneficial tool for students with special needs, because if they have a hard time deciphering which one is which, they can use this to help them figure out. But we should still push for students to attempt to find out the answer on their own without using that. This page is a page that will be implemented in the lesson. It is a note-taking page. This is just for students to try. It actually gives them, it lists all the tangrams, which are 2 large triangles, a medium, 2 small, a square, and a rhombus. And it shows how they are all put together. Now, students can take notes here that represent how they found the fractions. That way, they can take their thought process and put it on paper. Which is good because it allows the teacher also to see where they made a mistake and their reasoning behind certain things. So here's our note sheet, which will be turned in at the end of the lesson. Now, after that is completed, here's the actual worksheet that will be completed. Again, it lists the tangrams up at the top, the 2 large, 1 medium, 2 small, square and rhombus, and it shows them all put together, because that's not what this lesson is about. Even though we did in the beginning, that was just to get students familiarized with the tangrams. And then, here, I have numbers 1, 4, 7, 8, 9, 10, and 11 circles right here. Those ones our students should be able to find out because they all have the same common denominator. And what it does is it tells you to combine the tangram pieces. Number 1 says combine both large triangles. We know this one is a fourth, this one is a fourth, so 1/4 plus 1/4 equals 1/2. Not hard. Number 4. The median triangle and the square. This one might be a little tricky for students. If they have not figured out on their note section what each shape what the fraction for each shape actually represents, they're not going to be able to combine these to create a shape on here, which could provide some difficulties. So that one still may be a little tougher. And then 7, 8, 7 and 8 is 7 is 4 large triangles and 8 is 12 small triangles. We don't have 4 large triangles and 12 small triangles. However, students should be able to visualize them together to create the fraction that they need, their answer. It is also beneficial if y'all have already covered reflection, translation, for them to create their own tessellation on here to figure out these problems. Because they can trace the tangrams and make the shape that is being requested. Okay. Now let's see. I did not circle 2, 5, and 6. Because it's a small triangle and square, large triangle minus medium triangle, and a parallelogram minus a small triangle. So students may be able to look at it and solve it and be like, okay, taking one away. However, they do have different denominators with the fractions when they solve it. So that may prove difficult for some students because of the different denominators. I would leave those on the worksheet. So students who are GT may have why am I drawing a blank? Not confusing, some challenging questions so they are not bored with the worksheet. So that will be implementing tangrams with fractions, and good luck.